Hi everyone, welcome back to Math with Amala. Let's start a new part of your chapter. Number 7 of grade 10 coordinate geometry. Let's start with the Cartesian plane which has the horizontal line as x-axis, vertical line as y-axis. Then the x-coordinate which is the distance of a point from y-axis is called the abscissa. Y-coordinate which is the distance of a point from x-axis is called the ordinate. So we can mark a point P of xy in the plane. The coordinates or the ordered pair of a point on the x-axis are of the form x comma 0 where the y-coordinate will be 0 and of a point on the y-axis are of the form 0 comma y where the x-coordinate is 0 and y can take any value in the y-axis. Let's recall that graph of linear equations in two variables of the form ax plus by plus c equal to 0 is a straight line always. Likewise, graph of quadratic equations with a degree of variable 2 ax square plus bx plus c equal to y where a not equal to 0 is a parabola. Now let's find the distance formula for finding the distance between two points which are placed on a plane. Let's take P x1 y1, Q x2 y2. Consider triangle PTQ for finding the distance from P to Q. So we have introduced one more point T over there. Triangle PTQ is a right angle triangle since PT is perpendicular to QS. Hence by Pythagoras theorem, PQ square is equal to PT square plus QT square. From the coordinates of P and Q, you will get that PQ square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. That is PQ is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. You can give the reverse also x1 minus x2 the whole square plus y1 minus y2 the whole square since there is no change in the squaring portions. Remark. Distance from P of xy to origin O00 is always OP is equal to root of x square plus y square since the coordinate of origin is 0, 0. Find a relation between x and y such that the point xy is equidistant from the points 7, 1 and 3, 5. So we have marked them in a rough figure 7, 1 as A, 3, 5 as B. Then we have to find AP equal to and AP is equal to PB is given which implies AP square is equal to BP square since they are in equidistant format. That means by applying the distance formula, AP is x minus 7 the whole square plus y minus 1 the whole square that is equal to x minus 3 the whole square plus y minus 5 the whole square. By opening with the identity distribution, you can say x square minus 14x plus 49 plus y square minus 2y plus 1 is equal to x square minus 6x plus 9 plus y square minus 10y plus 25. And now by cancelling the equal terms on left side and right side, you can say that you are getting minus 14x plus 49 minus 2y plus 1 is equal to minus 6x plus 9 minus 10y plus 25. Now by grouping this equal terms together, minus 14x plus 6x plus 49 plus 1 is equal to 2y minus 10y plus 25 plus 9, that is equal to minus 8x plus 50 is equal to minus 8y plus 34. Minus 8x can be kept on the left side and take the plus 50 towards the right, you will get minus 50 there. Minus 8y plus 34 minus 50, and the final answer just by dividing with the minus 8 on all the sides or both sides, you are getting x equal to y plus 2, which implies x minus y equal to 2 is our required answer. Now let's move to the exercise number 7.1. Third question. Determine if the points 1, 5, 2, 3 and minus 1, minus 11 are collinear. Collinear means if all the points or the 3 points are lying on a same line, then they are called collinear points. And also they should satisfy AB plus BC equal to AC. If they are lying on the same line, this will be automatically satisfied. AB plus BC equal to AC have to be satisfied for being collinear. So we have marked the points on the given straight line. Now we can find the distance AB. AB is equal to root 5. Also BC is equal to 2 root 53. AC equal to root of 265. Here AB plus BC is not equal to AC. Now by adding AB and BC, it is clear that it is not equal to AC. You're getting hence the given points are not collinear. If they were equal to AC, then these 3 points are collinear and they are lying on the same line. Since it is not equal to AC, we can say they are not collinear. Now let's move to the next section, which is the section formula. This is to calculate the distance when there is a cutting in between two lines. Let's take point P is marked such that 2AP equal to BP. To know the coordinates of P, let us apply A similarity, that is angle-angle similarity criterion. The criterion states that two triangles are similar if two pairs of their corresponding angles are congruent or have the same measure. That is, when we apply this criterion in triangle POD and triangle BPC, OD by PC is equal to OP by PB, which is equal to 1 by 2. Likewise, PD by BC is equal to OP by PB, which is equal to 1 by 2. That means x minus 0 by 36 minus x equal to 1 by 2. Likewise, y by 15 minus y is equal to 1 by 2. By reducing the equations on left and right, you can get x equal to 12 and y equal to 5. Now p of xy is equal to p of 12 comma 5. You have got the x and y values. For OP is to PB is equal to 1 is to 2 because 1 is double the other. Generally, the section formula can be considering any 2 points A comma B and assume that P divides AB internally in the ratio. Internally in the ratio M1 is to M2. Then the coordinates of the point P are M1 x2 plus M2 x1 by M1 plus M2, M1 y1 plus M2 y1 by m1 plus m2. Here the denominator is same, only there is change in the numerators. Here we have some cases. When the ratio is k is to 1, coordinates of p will be kx2 plus x1 by k plus 1, comma ky2 plus y1 divided by k plus 1. Then the next case is the midpoint formula. When the cutting is at the exact half or middle portion, ratio is 1 is to 1. The coordinates of P will be x1 plus x2 by 2, also y1 plus y2 by 2. Example number 7. In what ratio does the point minus 4, 6 divide the line segment joining the points A minus 6, 10 and B 3, minus 8? Here we can use the section formula in order to find the ratio of the cutting. Minus 4, 6 can be written like 3m1 minus 6m2 by m1 plus m2, minus 8m1 plus 10m2 by m1 plus m2. If this xy is AB, then x equal to A and y equal to B, then you can substitute that. Therefore, minus 4 is equal to 3m1 minus 6m2 divided by m1 plus m2 and 6 equal to minus 8m1 plus 10m2 by m1 plus m2. Now we can cross multiply. For m into m1 plus m2 is equal to 3m1 minus 6m2 minus m1 minus 4m2 by distributing. You get that which is equal to 3m1 minus 6m2 which is equal to minus 4m1 minus 3m1 which is equal to minus 6m2 plus 4m2. That implies minus 7m1 is equal to minus 2m2. You can cancel the negatives. 7m1 is equal to 2m2. Now take the variables together. M1 by M2 is equal to 2 by 7. You got that ratio is M1 is to M2, that is equal to 2 by 7. We can find the same by using the next section also of 6 equal to minus 8 M1, that one. Okay, so the ratio is 2 is to 7. Example number 10. If the points A 6, 1, B 8, 2, C 9, 4, D P, 3 are the vertices of a parallelogram taken in order, find P. So we have marked the points in a quadrilateral or a parallelogram. The diagonals in a parallelogram bisects and coordinates of midpoint of AC can be written like coordinates of midpoints of BD. Okay, so 6 plus 9 by 2, 1 plus 4 by 2 is equal to 8 plus p by 2, 2 plus 3 by 2. That is 15 by 2. 15 by 2 is equal to 8 plus p by 2, 5 by 2. Now by equating the x coordinates together, 15 by 2 is equal to 8 plus p by 2. That implies p is equal to 7. Keep practicing and don't forget to follow this channel for more updates. Thank you all for watching the video. Please be stay tuned for the upcoming parts of your classes.